All right, let's talk about a huge challenge facing anyone who's trying to run a generative AI app in production: operational excellence. We're going to frame this whole conversation around one core idea: building a cockpit for your application, giving you all the instruments and controls you need to fly this thing safely and efficiently. So let's be real for a second. Does it sometimes feel like you're flying this incredibly powerful new Gen AI app completely blind? It's like you've built this amazing jet engine, but you're trying to navigate through a thick fog with absolutely no idea what's really happening under the hood.
And if that feels familiar, then you've probably run into some of these pain points. One day you get hammered with these unexplained latency spikes that are driving your users crazy. The next day, your cloud bill is just way, way higher than you ever expected. You're trying to hunt down these errors that fail silently, which are a total nightmare to debug. And the quality of the answers from your app just seems to be all over the place. Look, this isn't just you. This is the reality of trying to fly without any instruments.
But you know what? It doesn't have to be this way. The solution is to stop flying blind and to start right now building out your operational cockpit. We're going to walk through step by step how to install the gauges, the dashboards, and the warning lights that you need to get total visibility and control over your app's performance, its health, and, crucially, its cost. Okay, first things first. Every good cockpit needs reliable instruments. It's a simple rule. You just can't control what you can't measure. So let's dive into the absolute core metrics you need to be tracking. Think of these as your foundational gauges: your airspeed, your altitude, and your engine health. So your number one instrument, your airspeed indicator, is latency. But just measuring the total time from start to finish, that's not good enough. You have to break it down. You need to measure the latency at every single stage, from the initial API call through your back-end orchestrator into your vector store for the retrieval step, and then finally the model call itself. And it is absolutely crucial to know the difference between the time it takes for that first word to appear, that's your time to first token, and the time for the full answer, because both of those have a massive impact on how the user feels about your app. Next up is your error rate. But a single number that just says errors is basically useless. You have to know the type of error you're dealing with. Is it a 4xx error, which means there was a problem with the user's request? Or is it a 5xx error, which points to a problem on your server? Or, and this is super common with Gen AI, are you just hitting rate limits and getting throttled by the model provider? Knowing which one is key. And that brings us to the really unique gauges for our Gen AI jet. Beyond all the standard metrics, you have to be watching things like token usage. That's basically your fuel consumption. And for RAG applications, the retrieval empty rate is a massive quality signal. If that number is high, it just means your users are asking questions your knowledge base can't answer, and that's a direct predictor of getting bad responses. So what happens when a request goes really wrong and you need to figure out why? Well, you need a black box recorder, and that is the perfect analogy for a tool like AWS X-Ray. It literally traces a single user request as it flows through every single service in your pipeline. So when you're pulling your hair out asking, where on earth do those extra 5 seconds of latency come from? X-Ray is the tool that gives you the definitive answer. Okay, so we've installed all our individual instruments. Now it's time to arrange them into a single coherent control panel. A pilot doesn't look at 50 different gauges scattered all over the place. They have a dashboard that organizes all that information logically, so they can see the full picture in a single glance. And this right here is a perfect example of a simple but really powerful production dashboard. You see how we're grouping related metrics together? API health gets its own panel, model performance gets another. Your RAG-specific metrics are right below it. And this is so important. You have a dedicated panel just for your daily cost trend. This kind of setup gives you that immediate, high-level situational awareness.
Now, a dashboard is for monitoring, but alarms are for action. These are your critical warning lights. You don't want to have to stare at that dashboard all day long, so you set up alarms for the events that demand your immediate attention: a sustained latency spike, a jump in errors or throttling, or a sudden increase in your retrieval empty rate. These are the flashing red lights that are telling you to grab the controls right now.
So with our monitoring all set up, let's talk about flying efficiently. Because honestly, one of the biggest shocks with Gen AI apps is the cost. A huge part of being a good pilot is knowing how to manage your fuel consumption. And in our case, that means your token usage and your overall cloud spend. So where should you even focus your efforts? Well, this chart makes it crystal clear. The single biggest lever you can possibly pull to control your costs is model selection. It accounts for a huge chunk of potential savings. After that, smart caching, good prompt hygiene to keep your token counts down, and efficient batching of embeddings are your next most powerful tools.
So how do you actually use that biggest lever, model selection, in practice? You do it with smart model routing. The idea is really simple. You do not need your most powerful, most expensive model for every single task. For the simpler jobs, like classifying what a user wants or answering a basic question, you can use a much smaller, faster, and cheaper model. You save your big, powerful, expensive models for the really heavy lifting, like deep reasoning or summarizing a complex document. Okay, now for the ultimate test, an emergency. We're going to simulate a really common but pretty scary scenario, a sudden, massive spike in our costs. And we're going to use our brand new cockpit and procedures to diagnose it and fix it. You wake up one morning, you pull up your cost dashboard, and you see this. A 3 times jump in your daily spend. Your fuel consumption has gone completely through the roof, and that feeling of panic starts to set in. So, what's wrong with the engine? Your first instinct might be to just blame the model itself, right? But a good pilot checks all their instruments first. And when we look at our dashboard, we see that it's not just token usage that's up. Our embedding job count is also skyrocketing. And that points us directly to a problem in our data ingestion pipeline. Turns out the root cause is that our ingestion pipeline is re-embedding the exact same documents over and over and over again. The fix is to make that process idempotent, which is just a fancy way of saying do it once and only once. So you create a unique ID for every single chunk of text. Then, before you spend money to embed it, you just do a quick check. Hey, have I seen this exact chunk before? If the answer is yes, you skip it. Problem solved. And that re-embedding problem? It's just one of several silent cost multipliers that can sneak up on you. As you can see, it has a massive impact. But you also have to watch out for things like a software agent getting stuck in a tool-using loop. And you've got to be careful about creating custom metrics with too much detail, like, say, tracking costs per user ID. That's called high cardinality, and it can quietly make your monitoring bill itself explode. So let's wrap this up with a few rapid-fire takeaways. Here's the trap. Thinking you can just manually dig through logs when something goes wrong. That's like trying to fly through a thunderstorm by just looking out the window. The win is building a proper cockpit with metrics, alarms, and tracing.
Next up, logging. The trap is to log every single prompt and every single output, which is not only incredibly expensive, but also a huge security risk. The win is to use invocation logging selectively and to always treat that data as highly sensitive.
And finally, cost spikes. The trap is that knee-jerk reaction to immediately blame the model. The winning mindset is to check your data pipelines first. More often than not, the real root cause of a cost spike is hiding in issues like idempotency, caching, or runaway loops, not in the model itself.
And that really brings us to our final thought. Building this cockpit for your GenAI app isn't just some nice-to-have best practice. It is absolutely essential. Because if you can't see the instruments, you're not being brave,